Okay, the last question that was suggested was number 13 on page 586. On each of the Apollo lunar missions, the command module was placed in a very low, approximately circular orbit above the moon. Assume that the average height was 60 kilometers. So that's this piece, right? That's the height above the surface. Here's the module. So this piece is 60 kilometers. And then it says, and the moon's radius is 7,738 kilometers. So the R of the moon, the little r, 7,738 kilometers. And this is the height. And so from this, you can get capital R for the satellite. Just add them together. So 60 onto 38 should be 98. So 7,798 kilometers, which would be equal to 7.798 times 10 to the 6th meters, because you do have to change it to meters. Okay, so then it wants to know what is the module's period. All right, so we have the radius, and we know we can get from the back of the book the mass of the moon. So if I were you, I would use Newton's version of Kepler's third law. So r cubed over t squared is equal to gm over 4 pi squared. And we're looking for the period. So take the t up, the 4 pi up, the gm down. So it would become t squared is equal to 4 pi squared r cubed over gm. So 4 pi squared r is 7.798 to the 6th meters cubed over g 6.673 to the negative 11 Newton meters squared per kilogram squared. And the mass of the moon, if you look it up in the back of the book, is 7.36 to the 22. It's on page 955. Okay, and you'll get a t squared, which ends up being something like 3.813 maybe, times 10 to the 9th, second squared. Take the square root and get 6.1027. Not sure if the t squared number is actually right on, to the 4th. I know the answer's right, but I have a feeling I might have messed up that one, and I repunched it in, and I rewrote down the right t, but I don't know that I wrote down the right t squared. So if your t squared's a little bit different, but you get the same t, it's because I just didn't fix by mistake in t squared. All right, and then part B says, how fast was it moving? I would probably then do v is equal to 2 pi r over t, because we just found the t, we have the r. So 2 pi 7.798 to the 6th meters, and then t 6.1027 to the 6 seconds. And when you do this, you get 796.682 meters per second. It's a pretty good clip. All right. So we're going to talk about satellites a little bit, and then you're going to do more of these questions because you need more practice.